Okay, this is the fifth revision video for C1. It's on alloys and uses of metals. Now, normally the way they're probably going to test you on this is to give you some facts about different alloys. They'll give you all the components, they'll tell you the percentages, and then they'll probably ask you to evaluate their use for different things. So they might say which alloy is best and why. And you're going to have to look at the information in the table to figure out which metal you would choose for the purpose they have given you and explain it. Okay, but if we go through some facts, and it gives you some background as to which alloys you want to choose and why. So start off in the specification, it does reference the iron from the blast furnace, and that's called cast iron. It's not pure, it's about 96% pure, so 96% iron. It's brittle, so it's very hard, it's great, but it is also very brittle. So for that reason, we don't tend to use cast iron for much stuff. We tend to convert it into steel. So steel is an alloy, which means it's not a pure metal. It's not found on the periodic table because it's made up of different things. Most of the time, steels are made of iron and carbon, but you may find they've got an extra component. If there is, they will tell you what it is. You do not need to know it, but you may need to look at a table of results or something like that to figure out what else is present. You can have different types of steel depending on the amount of each of these in it and the presence of any other metals as well. So you can have a low carbon steel, so a steel that contains very little carbon, and that's great because it's easy shape. So if you want to be able to shape your metal, then a low carbon steel is what you want. If you want it maybe for more building or structural things, you might want to have a high carbon steel because that's very hard. So again, a different type of use for those two things. And then you'll probably have heard of stainless steels. So your sinks, your cutlery, etc. And they're great because they're resistant to corrosion. Okay, so 3 different steels with different amounts of metals in them give them different properties. Okay, we very rarely use pure metals from the periodic table because they're too soft. If you think about when you draw the structure of a metal out, you have nice neat rows. So you'd have something where they'd all be sat in nice neat rows. And so if you would draw a solid out, this is what you would be familiar with. And the reason being, with those all being pure, they're all the same type of atom and they can slide past each other very easily, which makes them very soft. Okay, so we often mix them with other metals to make them slightly harder. So you might have seen a diagram of an alloy which looks something like this, which has got now a different atom present. Those rows can't slide past each other as easily because it's got a different metal atom here, which makes them much harder. So they are useful. So we very rarely use a pure metal, because we often use alloys, so mixtures of metals. The metals they're probably going to reference are your transition metals. If you think about the very first chapter we talked about, and we talked about this transition metal blocks, the block in the middle of your periodic table. Okay, they are great because they are good conductors of heat and electricity. So the metals in your computer, in your circuit boards to make those work are probably transition metals. Heat as well. So they are really good conductors of both of those things. So anything where you want to be able to conduct heat, conduct electricity, you're probably going to be using a transition metal. They can also be bent or hammered into shape. So pipe work, for example, copper pipes often made out of your transition metals. Okay, so useful as structural materials. So here are 2 examples then. Copper has properties that make it useful for electrical wiring and plumbing. So you've seen copper wiring and plumbing, copper pipes. And that's because for the electrical wiring, it can conduct electricity. And for plumbing, you can bend or hammer it into shape. Aluminium and titanium are also examples of transition metals and are very useful because they're resistant to corrosion. So you might have use of either of these, titanium in particular, for example, a hip replacement because it's lightweight and resistant to corrosion. Both might be used in aeroplane manufacture, bikes, etc. because they're also low density, so they're light, they're very light metals. Okay, so that's what you need to know in terms of alloys and uses of specific metals. If they've given you the name of another metal, they will have given you the information in the question to be able to answer it. So you might need to read back through and see what other information you can get from the question to help you answer it, because this is what you need to know from memory. The rest of it will be provided for you. Okay, so we've looked at iron being from the blast furnace, being great, it's nice and hard, but it is brittle. So most of it's converted into steels. Steels are alloys, which are a mixture of metals. They're much stronger than pure metals because they can't slide, the layers can't slide past each other, and then some examples of transition metals and why they are useful. Okay, so that's the end of the 5th revision video for C1.